Okay, in this video, we are going to be talking about graphing rational functions. So we're going to be putting together what we know about asymptotes, intercepts, and other important parts of a graph in order to sketch a graph of a rational function. We're also going to add in two new components, which is identifying the domain and the range. So this first set of information should mostly just be a review. It's kind of like a quick look at how to find the important features of a rational graph. So remember, when you're finding vertical asymptotes, you set the denominator equal to 0. And you're going to write the equation for a vertical asymptote as x equals something. Horizontal asymptotes, if the degree on top is smaller than the degree on the bottom, then y equals 0. If the degree on the top is bigger, then there is no horizontal asymptote, and if the degree on the top and the bottom are the same, then you find a fraction with the leading coefficient of the top over the leading coefficient of the bottom. With x-intercepts, to find them, you set the numerator equal to 0. With y-intercepts, you plug in x equals 0 to the function and evaluate. And then let's talk about the domain and range a little bit. So remember, your domain is all the x values, so all the inputs you can plug in. So for the domain, it includes everything except for vertical asymptotes. And remember, vertical asymptotes are the numbers that make the denominator 0. So basically, you can't have any number that makes the denominator 0, so your domain is going to include everything except for those values that are also vertical asymptotes. You should write your domain in interval notation, so it'll look like negative infinity, comma, a number, and the number will be where your vertical asymptote is. And then you have this little U symbol. This U is kind of like a mathematical and. Okay, and you're going to do the same thing with the range. So range is going to include everything except the horizontal asymptotes. And you're going to write that in interval notation as well. So let's take a look at some examples. So here I've actually given you the picture of the graph, and we're just going to identify the key features using the equation in the graph. So we're going to start by finding our vertical asymptotes, which is setting the pieces of our denominator equal to 0. So we have x minus 3 equals 0 and x plus 5 equals 0, which means that x equals 3 and x equals negative 5 are my two vertical asymptotes. And you can see that that matches up with the graph on the right as well. With horizontal asymptotes, we look at the degree of the numerator and the degree of the denominator. Remember, the degree is the biggest exponent. So the degree of the numerator is 1. The degree of the denominator is 2. Because if I were to multiply these two sets of parentheses together, I would get an x squared on the bottom, plus and minus a bunch of other stuff. So the degree on the bottom is 2. Whenever the degree on the bottom is greater, it means that y equals 0. Okay. So to find my x-intercept, which is my next step, I'm going to plug in 0 for my y, which means I'm just going to set my numerator equal to 0. Okay, I'm going to subtract 4, so I get from both sides, so I get 2x equals negative 4. Then x equals negative 4 over 2, which is just negative 2. And you can see that showing up right here as well with my x-intercept. For the y-intercept, I'm just going to plug in 0 for all of my x's, so I have 2 times 0 plus 4 over 0 minus 3 times 0 plus 5. If I multiply that together, I'm just going to get a 4 on the top, and the bottom I'm going to get a negative 15. Okay, so I should write this as an ordered pair, so I have 0, comma, negative 4 over 15. I should also write my x-intercept as an ordered pair. I forgot to do that. Negative 2, 0. Okay, so let's look at our domain here. So my domain, remember, is all the x values that I can plug in, and it looks like I can plug in every x value except for 3 and negative 5. So I'm going to write that. So I'm going to say I can go from negative infinity all the way up to negative 5. Then I have to take a break. Then I'm going to put this little union sign, which means I'm going to pick back up again right on the other side of negative 5. And then I'm going to go all the way to 3. Then I have to take a break because I have a vertical asymptote. Then I'm going to have another chunk of domain from 3 to infinity. So you can kind of, if you look at the graph on the right, you kind of see 3 different chunks of graph, right? One on the left, one in the middle, one on the right. And these domains kind of represent each section of the domain represents each chunk of the graph. So the domain, that's the domain. The range is going to be what y values I can plug in. Now the only y value that may be excluded from a range is going to be the horizontal asymptote, which in this case is y equals 0. But also in this case, we see that the graph does actually cross the y-intercept. So I actually don't have any disruptions in my domain. Even the horizontal asymptote gets touched once. So my domain is negative infinity to infinity. Okay, let's do another one where we get to create the graph. So, starting with finding our vertical asymptotes. Remember, the vertical asymptotes are the values that make the denominator equal to 0. So the x minus 2 is going to give us a vertical asymptote of 2. And the x minus 3 is going to give us a vertical asymptote of 3. So let's come over here and we'll actually sketch in our asymptotes as we go. So remember that we like to denote asymptotes using dotted lines. So I'm going to use a red marker. So I have one at 2 and one at 3. Ooh, that's going to be kind of a hard graph to draw in the middle. Okay, horizontal asymptotes. Here I look at the degree of the top, which is 1, the degree of the bottom, which is 2. So my horizontal asymptote is y equals 0 because the degree on the bottom was bigger. So I'll sketch in my horizontal asymptote. Okay. If you're having a hard time remembering how to find asymptotes, I suggest you go back and watch the video 5.2, which talks about how to find those asymptotes. All right, for the x-intercept, I am going to set the numerator equal to 0 to get that x equals 1. So my ordered pair would be 1, 0. So I'm going to come over here, and at 1, 0, I'm going to have a point. Okay. Then for my y-intercept, I'm going to plug in 0 for all of my x's. So I have 0 minus 1 over 0 minus 2 times 0 minus 3, which is going to turn into a negative 1 over positive 6. So I have a point at 0, negative 1/6. Let's go ahead and plot that. 0, negative 1/6. It's going to look something like that. It's not exactly perfect, of course. Okay. Oh my goodness, sorry. I zoomed in a ton. Okay. So my domain, remember, is all the x values I can plug in. So the only x values I'm not allowed to plug in are the values that make my denominator equal to 0, which are 2 and 3. So I'm going to go from negative infinity all the way to 2. And then take a little break, pick back up again from between 2 and 3. Take a break and then pick back up again from 3 to infinity. So remember that when I use the parentheses here, it means that my graph is going to get infinitely close to 2 or to 3, but it's never going to touch it, which is exactly what happens at a vertical asymptote. Then my range is going to be all my y values. And again, the only y value that may be off limits is your horizontal asymptote. In this case, we actually know that we have an x-intercept, a point that lies exactly on the horizontal asymptote, so we do not have any restrictions in our range. Okay. So now we have an idea of what our graph is going to look like, right? We know what the asymptotes are, we know what the intercepts are, but we still don't know a ton about the graph. So for example, if you look at the right side of the graph, I could have my graph going like this or like this. We got to figure out which one it is. So here is the easiest way to do that. I'm just going to plug in a value, like an x value, in every chunk or in every section of my graph. So I'm going to plug in x equals 4 because that's on the right side of my graph. So when x equals 4, I'm going to plug that into my equation. I get 4 minus 1 over 4 minus 2 times 4 minus 3. So I have 3 over 2 times 1, so I have 3 halves, or 1.5. So at 4, I have a point at 1.5. So that kind of tells me that this chunk of the graph is going to be on top of the horizontal asymptote. Okay. Now we've got a kind of tricky situation in between our two vertical asymptotes because the vertical asymptotes are so close together. So if I want to plug in a number that's between 2 and 3, I'm going to have to plug in something like 2.5. And if I'm doing 2.5, you might just want to plug it into a calculator. And that's totally fine with me if you want to do that. and kind of get an approximation for what that would be. So I want to pull out my calculator. You can totally do it by hand too, but if you want to do it with your calculator, you also can. So if you plug in negative 2.5, let's put that up here, negative 2.5, then you get the value of negative 6. So negative 2.5 has a value here at negative 6. So I'm going to guess that this middle piece of the graph is going to do kind of like a little upside down U shape right here. Okay. Now if you drew this middle piece of the graph a little bit differently, that's okay, but I do want you to check at least one point between the asymptotes to make sure that you've at least got 1 point right. Now on the left side of my graph, I already know 2 points. I have my 2 intercepts that are already here. But it still doesn't quite tell me as much information as I might want, okay? So I'm going to plug in another point over here. I'm going to plug in maybe something further over here like negative 3. Okay, and again, you can use your calculator for this if you want. So when I plugged in negative 3, I got negative 1.33, okay? Which means that probably by the time I'm at negative 3, I'm already getting really, really close to my horizontal asymptote, which makes me think that maybe it's going to be going like this. And then right here, it's going up. So on this left side of the graph, it seems like I came down and then I approached back up to my horizontal asymptote, which is okay. So it's easy for these to get messy pretty fast. So you want to make sure you're just taking extra care to make sure that you're plotting the right points, you're looking at the right asymptotes, and you are plugging in points correctly and accurately. Okay. I'm going to work through these next 2 examples, but I'm going to do it in another video so that I can take my time doing them. So if you feel like that's enough and you're ready to move on to the homework, go ahead and do that, or go ahead and jump on to the next video.